Hello. Welcome to this talk about Windows Azure Notification Hubs. We will be talking about how to deliver push notifications to millions of mobile devices. If there is one thing that I want you guys to take away from this talk is that with notification hubs, it's easy to send push notifications in a multi-platform way, and also to make those notifications personalized. And you can send them both to interest groups, single users, and very, very large groups. And this is made really, really easy. This is what we will be talking about. There will be a very first introduction on push notifications. First, I wanted to know how many people are familiar with push notifications, channel URI, device tokens, registration IDs, those things. OK. So we will definitely see a little recap on how these things work and how they're usually hard to set up and implement. Then we're going to provide a motivation on why notification hubs are important and are actually a very, very good tool to solve this problem. There will be a little demo for that. We're going to talk about tags, which allows you to route notifications to specific devices. We're going to talk about how to make this registration secure, how to basically get only certain devices to register for certain tags and interest groups. And we're going to see how to use templates to provide personalized notifications. There are going to be many demos, and so let's just get started. First of all, push notifications is essential to the experience of many, many apps. They increase user engagement. They allow you to update tiles, to display relevant information in real time. Basically, they provide you a hook to reach millions of people, everybody that have your app across the world. However, when you put the push notifications into your app and you deploy a real world app, sending one single push notification is usually complicated but not that hard. The problem is that real world apps starts having a lot of extra requirements. You might have a multi-platform app. Then you have to start handling channel URIs of different platforms. You have to remember which device is which. You might have to take care of localization. You have to send notifications in multiple languages. How do you do that? You might have different user preferences. Some users might want to receive weather updates in Fahrenheit degrees, and others might want to receive weather updates in Celsius degrees. You might have different client app versions. A deep link might work in your V1, but might not work in your V2, or vice versa. And then, of course, there is scale. When you have millions of devices, but not even that much, even hundreds of thousands, it's very, very hard to provide real time to these apps. Just to have an idea, the Windows News apps that is installed in all your Windows 8 tablets is using notification hubs to broadcast breaking news. That basically, when something happens, you will have a toast pop up on your Surface or on your desktop PC that will tell you that something happened. That has to be a very quick delivery to millions of devices. So push notifications, they require a platform-specific service. So a Windows Store app requires you to use WNS. Windows Phone requires you to use MPNS. iOS apps requires you to use APNS. And Android requires you to use GCN. These are all different services. They have different protocols. They have different capabilities. And they require you to do slightly different things. and an end-to-end solution requires lots of back-end code. You have all these handles, all this device information that you have to store, and you have to implement platform-specific protocols for all these platform notification services. Now, let's look very quickly at the life cycle of a push notification. Some of you are familiar with this, but just so that everybody's on the same page of why this is a hard thing to do. When the client app launches, here we have a Windows Phone app, what happens is that it contacts the platform notification service and it retrieves a specific handle. That is a different form of handle depending on the platform. For Windows platforms, those are called channel URIs. Then you take this handle and you have to send it back to your backend. This is all code that you have to write. You basically have to write a little REST service on the app backend that takes its channel URI and stores it somewhere. When you want to send a notification, you have to retrieve this token or a handle or a channel URI and contact the platform notification service mentioning that handle to send a notification. So what happens is that you have in your backend a big registry of all these handles, which also is not really working anymore. Okay. It has to be maintained. So what happens is that these handles, they expire. You have to keep them up to date, and they have to be deleted when the platform notification service expires them. So what are the challenges? Of course, platform dependency. We already talked about this. And then there is routing. Every platform notification service allows you to send a push notification to a single or maybe multiple of these specific handles, channel URIs, tokens. However, usually your app wants to send a notification to a user, to an interest group, to a specific market or region, to a version of your app. So what happens is that you end up creating these associations and managing these associations in your backend. That is a lot of code. And of course, scale. If you want to broadcast to millions of devices, and even if you just want to manage all these millions of devices, you have to keep something in your backend. So how does Notification Hubs makes this easy? There's a one-time setup. You create a Notification Hub inside of Windows Azure Service Bus. And then what happens is that when the client registers, you retrieve the handle from the platform notification service and you store it inside of the Notification Hubs. After that, your app backend sends a notification to the Notification Hub, which then uses the correct platform. You do not have to know which platform, which device is which. You just send one notification to the Notification Hub, and then we route it through the correct platform notification service to the device. So, of course, the advantages are there is that you have no platform-specific protocols, no need to know that the Apple notification service has a feedback channel. You do not have to store all this device information inside your app backend. And also, you can basically push a notification to millions of devices with a single call. You do not have to batch the work. You do not have to make it asynchronous, create a worker role, or do any of that. We basically are always ready to send a notification to all your app users with a single function call. Now, let's do here a little get started demo. Here I have a Windows Store app. Of course, Notification Hubs work with all platforms. Since this is the build conferences, we're going to build a Windows Store app. Here I have one configured in the developer dashboard. Inside of services, I get my credentials for WNS. These are the things that will allow the notification hub to contact WNS and to send notifications to my app on behalf of my backend. Then I go in the portal inside of Service Bus. I have a namespace with a list of notification hubs. The first one of those has those same credentials, which I copied. These are the credentials that allow the notification hub to send the notifications. Now, I will create an app from scratch that will basically show how easy it is to configure an app for notification hubs. So this is a blank app just created. The first thing, we will want to receive a toast. We actually have to go in the app manifest and make it toast capable. Then what we will do, we will associate this app to the credentials that I have in the store. So bear with me while I enter my credentials. And hopefully this is correct. Okay, this is the app that I got from, that I configured in the store. And I associate this project with the app that I have in the store. Now, when I ask a channel URI, this app will get the channel URI, the handle that's for to be reached with push notifications. Then what I will do, I will have to download the notification hub DLL. That is here NuGet package. Once I have that, I will basically create a simple notification hub singleton inside my app. And on launched, what I will do is that I will initialize my notification hub with the name of my notification hub, which was called build hub. And then it has to know the credentials to access this hub. These credentials are, these credentials are in the portal. So we go in the portal. We go back to my dashboard of the build hub, and we click on connection string. In here, I have two keys. One is has listen access. This is the one that we actually want to use in our app. So we copy this one, and we paste it here. After that, we're gonna use. We're going to have to register with the notification hub. So we're going to do a couple of network calls. We do not want to block the thread. We're going to just create an sync method for that. Okay, this is an async method. And in here, the first thing that I have to do is to go and talk with WNS and retrieve a channel URI. This is the handle that I will use to register. Okay, I will have to import my notification. I'm creating a channel for my application. And here I have my channel. Now, then I have to take this channel and register the channel URI to the notification hub. So I get my hub that has been configured, and I will register for native notifications, which means that the server will specify a WNS payload. And in here, I will actually have to specify my, this is an async app. and a sync method. Okay. And I specify my channel URI. Now what happens here is that every time my app launches, it will go to WNS, get the updated channel URI, and update this device registration with this specific channel URI. Now let's make sure that this works. Of course, we retrieve our channel URI. This is how it looks like. And then we're going to go and talk to the notification hub and register for it. OK, this is a complete blank app. This is the only code that I wrote in here. It doesn't have to be running. Now, the registration is stored inside the notification hub. How do I send a notification to it? Well, I can do it with any .NET app or Node app or even a mobile service. I actually have here a mobile service that is a complete empty mobile service. It has just been created. I did not even follow the get started. There's no table, no APIs. There's just one single scheduler. Inside the scheduler, there is a piece of code that is connecting to my notification hub and sending a toast. People that used mobile services before for push notifications will recognize that the format is exactly the same. Instead of typing push.wns.sendToast, you basically use the notification hub service. This is part of the Azure SDK for Node, which you can download. The source is on GitHub. You can use it from any Node script that you have. And then when we run this script, if everything worked, we should see a notification appear. OK, here it is. So what we did here, this is, I coded everything from scratch. There's no channel table in your mobile service. You do not have to maintain them, make sure that they're expired. You do not have to do anything like that. Also, notice that in here, we never specified the channel URI. We specified here null. That's where you usually, in your push.wns mobile service, you would put the channel URI. For notification hubs, you would basically put your tag that you're sending to. In here, we're just doing a broadcast to everybody. So this same function call will basically push a notification to all the clients of your app, just with the code that we wrote. If you want to have a simple please upgrade my app or something like that, this is the only code that you have to write. And this will work if you have 1,000 clients, 10,000 clients, 100,000 clients, 1 million clients. You do not have to do anything. So this is basic. Then, of course, you can do all of this from .NET too. So let's go in our app here. Let's do a simple, let's add here another project. Just to make sure, we'll just use like a console app. There's really no need to use anything else. You can call it from your worker roles, web roles, any C#.NET code. In here, we're gonna add the service bus preview features, DLL, which is here. This has one class that allows you to communicate with notification hubs. Notification hub client in here, using notification hub. Again, we use our connection string. In here, you have to use the connection string that has full access. This is the one that allows you to create registrations. You might want to know how many registrations you have. You might want to modify the credentials if you want to do those things. You might want to, and of course, sending the notifications. So we paste this here. Our hub was called the build hub. And then here we have a payload. And here I just have like a simple payload for a toast in XML. Our friends in the WNS team are going to release a nice NuGet package with a helper to do all these things. It's gonna be called notification extensions. There is a sample already out for that. So right now you can just use XML code. And then from hub, in here we will send Windows notification. And we'll provide this payload. And this console app does exactly the same thing. We'll just send a notification from .NET. This is actually, the latency is pretty fast. OK, let's go back to our presentation. OK, this was the getting started from scratch. It's really, really very easy. However, well, let's first take a look at these things. If you download the slides, you're going to have all the snippets. This is how you register, really, really easy. This is how you broadcast with .NET. Again, it's 3 lines of code. So basically, 6 lines of code, and you're broadcasting to millions of people. If you have an iOS app, we do have an Objective-C. If you download the Azure SDK for mobile, the iOS, you're going to find 2 frameworks. The one for mobile services and another one for notification hubs. This is the Objective-C code to register for notification hubs. This is the only thing that you have to, well, you actually also have to write some code to handle the notification when it comes, but that's standard iOS. Android, same idea. You go from GCM, you register, you get a registration ID, and then you call your hub.register. Broadcasting, very easy. You provide the payload and you send to Apple, you send to GCM. From Node and mobile services, just require the Azure SDK. This is the same code that we saw in the mobile service. What are the takeaways? You do not need to store the channel URIs anywhere. There was no table, no nothing. You do not have to deal with maintaining those. You do not have to update them. You do not have to do anything with them. However, these device registrations do expire. Why is that? For 2 reasons. Channel URIs, tokens, they expire on their own. So if you do not update them, they basically become useless on their own. So we maintain them for you. And also, you do not have to do any cleanup when people uninstall your app. You will not have like these dangling registrations that you do not know what to do with. For that reason, you basically have to call register regularly. In the sample that we just saw, it was called every time the app started. In this way, you make sure that the registration is alive, and you also make sure that the channel URI is up to date. If you do have an app where sometimes the user is where you're providing like a very good experience just with the tile, that sometimes happens with Windows Phone and Windows Store apps, like weather apps or financial information. You're providing good value just for the tile. You can use a background process to register regularly. Now, we did see how to broadcast to everybody. Now, how do you actually send a message to only some devices? Not all the times you want to send a notification to everybody. So what happens here is that you can use tags as interest groups. So for instance, you can have a phone registering to follow the Wailers and another tablet that wants to register for the Beatles. And then when something happens about the Beatles, what we do is that we route the notification to only the devices that register for a specific tag. Tags are just strings. So anything that makes sense in your app, user IDs, band IDs, interest group IDs, whatever you want, you just use the tag, and you can start like sending and receiving. You can start sending things to tags even if they don't exist. What will happen is that we'll just don't do anything with it. You can also use tags for multiple kind of interest groups. So I don't know, you want to have people that can follow like both bands and users, and you can also use tags to tag the devices with user ID. So that's something when you send a message to Elio, all my mobile devices are going to receive that notification. You do not have to know how many the devices I have. Most of the time, you don't care. Okay, this will be another demo that is called Media App. Why is that? Let me, since we do not have lots of time and there are lots of demos, I will not really go from this from scratch. So let me just start it. What this is that this is an app that sends me notification regarding news. So I assume to be in a certain market. So in the US, I can be in Europe, in Italy, France, Germany, and then I can subscribe with for different categories of news. What this does underneath the covers, I just register for those tags. I register for the market as a tag, and then I can register for world news, for sport news, and these sort of things. So what happens here is that, let me remove all the registrations. Of course, when I go in my backend, the backend is a simple send. This will just send world news, since I'm not registered to world news. When I run this app, when I send this message, I will not receive anything. Now what happens, of course, when I go in here and I register for something, for world news, what will happen is that I will receive the notification. Now, I want to point one important thing. When I do register for these categories, of course, they're tags, and they will be stored in the registration inside notification hubs. But registrations do expire. So you do not want to use your registrations as a storage system. It's true, you can retrieve the registrations, you can see what tags are in there, you can do all those things. But the thing is that you're never guaranteed that the registration will still be there when the user restarts the app. The channel URI could have been expired, the whole registrations could have been expired. So you have to store these preferences somewhere else. What I do in this app is that I just use the local storage. You can use mobile services, which makes that very, very easy. But basically, you do not want to use the notification hub as a storage system. In here, what happens when I sync the preferences with notification hubs, what happens here is that I generate a list of tags in here with this little link. I add my market. So what happens here is that I will have in this list, I will have my market, English, and a single tag that's called World News. I get my WNS tag, and I register with the notification hub. Notice I also remember when I synced for the last time. I do not want to sync too many times. If the user opens the app 30 times in an hour, I do not really want to refresh that too many times. Okay, and this is done. Also, what happens here in this notifications class is that I also sync the preferences on launch. So what happens when I run my app, I make sure that all my preferences that are in my storage, that I'm still registered for all these tags. So I read the things from storage and I resync. Now, of course, this app doesn't have to be running anymore. When I run my backend and I do send a world news, I actually receive the world news. Okay, this thing is basically a pattern that we see happen over and over and over again. We have many customers that what they're doing is basically just this. They want to send something to their. This is basically what Bing News is doing too. When you register for your news app, you have your notifications. This is what they're doing, and this scales up to millions of those devices. You do not have to worry about anything, and this is a very, very easy way to target specific devices. You do not have to store them. You do not have to maintain the channel URIs. You do not even have to know if you have multiple platforms. You do not have to know that who has iOS and who has Windows Store. So what are the takeaways? Please store the tags and the categories somewhere. Do not use the Notification Hub as a storage system. We do not charge as a storage system, and we were not meant to do that kind of work. There are like many other better alternatives, like mobile services, for instance. Make sure also to register regularly. Rule of thumb, at every app starts up to once a day. That's good. If you do not want to do it all those times, maybe your app wants to save on network call, wants to be like very considerate about users' data plans. You can reduce that thing with the caveat that some people might be unregistered. So these are the big two takeaways. Now, I have here the next section is securing tag registrations. Why is that? If you want to use tags as a user ID, you basically do not want to do the thing that I showed you. Why is that? If you noticed, in the app, I put the list and credentials of the Notification Hub. That allows to create registrations, any registration for any channel URI for any tag. I do not want anybody to register for a tag that is user ID column Elio that is not me. Otherwise, my notifications will go somewhere else. So what happens is that the previous scenario works really, really well for apps that are sending public notifications. Things like news, things like updates, RSS feeds, things where basically you're sending to an interest group. You're not sending to a specific person. It's not like private information. If you want to do that, you have to register from the backend. What does that mean? Is that the device does not contain any credentials. People sometimes try to find out like inventive way, like, oh, I'm not storing the credentials in the device. I go back to the backend, and the backend sends the credentials back to me, and then I register. That ends up being like 2 round trips instead of 1. Once you're calling the backend, just register from the backend. What you do from there, you basically the device, instead of calling Notification Hub, takes the channel URI and goes to your app backend, maybe a mobile service or maybe ASP.NET app. And it says, I want to register for this tag, and this is my channel URI. What happens is that the backend now can authenticate your device with mobile services. That's really, really easy. For ASP.NET, you might want to go, I don't know, for enterprise apps, you might want to go and hit an Active Directory. That's basically not what Notification Hubs does. Notification Hubs does not provide you an authentication mechanism. We compose with other authentication mechanisms. And then what happens is that the backend, once it makes sure that that device can register for those tags, will register with Notification Hubs. So the same registration patterns apply. So you want to register regularly. It's the same thing. It's instead of doing register to the Notification Hub, you're registering to the backend. And again, store the tags and the things that are important, not in the Notification Hub, but in your app. So let's look at another demo that I called Notify User. This one, it can be coded in mobile services, since most people tend to be more familiar with C# code. I actually did an ASP.NET app, but the same thing can be coded in Node. What happens is that inside my backend here, well, first let's talk about the client. With the client here, what I do is that I generate locally an installation ID on the device. And then I use that installation ID to tag my registration. What happens is that then the backend can retrieve the registration by tag and can basically look for the registration for this specific device. This is really very easy to do. I have here this local storage manager, which basically gets an installation ID. The code is super easy. What I do is that I create a container with a key that's called installation ID. If it's not there, I create one. Otherwise, I just return it. And then what happens is that when I want to log in, I basically just call my backend. This is, I create a JSON object with the installation ID, the channel URI, and the user ID. The user ID can come from the client, or can come from the or can be retrieved by the backend by doing some other form of authentication. And then I just do a post on my ASP.NET backend. In there, I have a web API controller here with that answers on post, that parses the input, make sure that I'm authorized. And here you can have many things. Maybe I'm not just registering for a user ID, I'm registering to receive updates about a division or about an organization. And so you might want to have some logic there depending on your app. And in here, what I do is that I got my hub client, created as we already saw. You get the connection string with full access. That will be the only connection string that you use for this particular scenario. And then you get all the registrations using an installation ID. And then what happens, if all your data is clean, you will receive only one registration. So in here, I do handle the case when you have more than one. This should never really happen. Maybe when you're developing and this code is not really working correctly, you might have that case, but that should never happen. So what happens then is that I get my registration, I update my channel URI, I update my tags. Notice that I'm tagging with both the installation ID and the user ID. And then I update my registration. What I also do, I also send a notification to that user saying, hello, user. OK, now let's see this working. Let me attach this debugger to my backend. OK. Now, if everything goes well, I should have here my installation ID. I have here a very simple user ID. Well, it did not attach correctly, but the backend is working, and I got my notification back. So what this does, notice that in my Windows Store app, I do not have, let me actually open the, I do not have any reference to the Notification Hub DLL. I actually have no Notification Hub DLL. That's because it's not talking to the Notification Hub directly. In order to be secure, it's just talking to your backend, and then the backend is contacting the Notification Hub. So use this pattern when you want to send notifications to when you do not want to send public notifications, when the notifications need to have a little bit of privacy. Now, a couple of extra words I want to spend on that, and is that push notifications are not really secure. So no platform notification service guarantees anything regarding the security of push notifications. So the guidelines that all the platforms say is that you should never send personal or sensitive information via push notifications. The push notification has to be an alert, or prompt an action from the user. But then the real data, as always, always has to appear inside the app. So delivery is not guaranteed, and the security of those notifications is not guaranteed. So please remember that when you're coding your apps. So this is the code that we already saw. It's not really that complicated. What you do is that you just take the notification by installation ID, and you update the channel URI and the tags. The only thing that you have to do from the client, you basically do the same thing. You make sure that you register regularly, and you, of course, re-register when something changes. So the takeaways are, of course, if you need security, you have to handle registrations from the backend. And notice again that the SDK is not required on the device in that case. Let's see now how to use templates. Templates are a very, very nice feature, and that solves the problem of obtaining a platform-agnostic backend. Right now, we are sending a platform-specific payload. So your backend is actually crafting that XML that Windows Store wants. It will, if you have a multi-platform app, you actually need to create the APNS payload too. You need to know that you have to send both. You do not have to know if what platform what platform each one of your device is using, but you basically have to still craft more payloads. What happens here is that we have a way to make your backend platform independent. This is very important in situation where the backend team and the client app teams are different. So sometimes that happens in big orgs, that you have somebody that is responsible for the backend and for sending notifications, and there are sometimes multiple client app teams that are developing the apps. In those cases, changing the format, changing how things have to be visualized are usually a hassle. So you have to do extra coordination. In this way, we have like a nice platform independent surface. What happens here is that when the device register, they specify a template. In this case, we have a surface that is specifying a Toast template, and notice the $ message in there. What it says there is that is the format that they want to receive. So they want to receive Toast, and the actual message that comes from the platform agnostic notification will have to be inserted in that way. Then we have an iPhone that is registering for the same Toast notifications, and in this case is using the JSON format for APNS. And notice that again for the alert, it's referring to the same message. What happens then is that the app backend will send one platform agnostic message, which is basically a dictionary of strings. And what happens is that Service Bus will perform what is basically like the mail merge function of Word, will create individualized notifications for all the platforms, and will basically deliver the notification as those devices has specified. This also makes sure that things can be independent by version. So what happens again is that you might have different versions of your client app. You might have a certain deep link that works only in V2 but not in V1. What you can do is that those changes can be embedded in your template, which is basically bundled with your app. When you deploy your new app, your backend doesn't have to remember that certain clients have a V1 version of your app, and other clients have the V2. So what you can do is that you just send the same message, and the V1 clients will just use a certain set of attributes, and the other ones will just use a different one. So templates can also be used for personalization. So again, in here, let's assume that our surface here wants to receive weather notifications in Fahrenheit degrees. In here, of course, you can have like a more complex situation just to fit it in a slide. I just have the temperature there. And an iPhone wants to receive the temperature in Celsius degrees. What happens is that then the backend can send both temperatures, both pieces of information, and then what the notification hub will do is that it will provide a personalized notification to each one of the devices. This can be used for many other scenarios, like localization. You might have a French string, an English string, a Spanish string. You might have a set of stock tickers, and everybody might want to only display their favorite ones. So there are many, many ways in which you can make use of this feature to personalize notification and to very quickly and very easily provide a personalized experience. You can have, for instance, constants like I have here. I can say, I can register for a template that says, Elio, some friend of yours added you to this group. And that can be a notification for me, while in the back end, I actually just sent a notification that says, this person added all these people to the groups. Okay, let's look at a quick demo for this. Okay. Let me run this app. What I have here, I actually used geolocator to get our location, and the Bing Map APIs to retrieve that we actually are in San Francisco. And then I can choose if I want to receive a weather update in Fahrenheit degrees or in Celsius. So what happens here, I can choose Celsius, and I'm registering. When I do this, I am making sure that my tag doesn't have spaces. I will create the property that I want, either temperature in Celsius or in Fahrenheit. This is Celsius, great. I will call the scale, and then this is basically the expression that we'll use, which is basically that will say something like temperature in San Francisco is a certain temperature that I specified. Then I will of course get my channel from WNS and register a template with the notification hub. Look here, we have a couple of extra things. Instead of just having the channel URI and the tags, we also have the template, which is the big TextToast template that we have, and a string that it's called temperature toast template. That is because when you create template registration, you actually can assign a name to it, because you can have more than one. You can register for multiple templates for different tags. I might want to receive a tile for that same kind of data, which is extracting, I don't know, maybe an image and same temperature. So you can register multiple templates and the same backend stream of data. So temperature updates can result into multiple notifications, even for the same device. You might want to receive a badge that something happened. Okay. So this is registering for the temperature in Celsius. And then here we have like a very simple console app. I really cheated in here. I just coding the temperature. But basically you see how you send the platform in the independent message. Notice that I'm just creating a dictionary of strings. And when I send the message, I'm not specifying the platform. This message will actually go to clients of all platforms. You do not have to worry about whose device has what platforms do you have. There is nothing that pertains to presentation, to XML things, or like to assets, image assets in your client apps that is here in the backend. Now, of course, if we run this project, what will happen is that we will receive the temperature in Celsius. Again, now without changing anything in my app, in my backend, I will register now for Fahrenheit degrees. Oh, this is the wrong one. Let me run this again. Oh, no, it was just that. Well, anyway. Okay, so I will register again, but for Fahrenheit degrees. So again, here we're creating my template. I'm registering again. And what happens is that now the same message will result in a different notification. I will receive actually that the temperature is 76 Fahrenheit degrees and not Celsius. Your backend is completely independent of user preferences, localization, and things like that. Okay, we have 10 minutes. This is pretty good. What are the takeaways? You can have platform-agnostic code in the backend. You do not have to do lots of code to basically manage this big registry of SHA-ARIs, handles, registration IDs, device tokens, keep track of which versions they are, and keep track of what users they are, and make sure that they're kept up to date, and cleaning them up when things when the apps are uninstalled. You can have all the versions can be abstracted away. All the different client apps versions by locale, by actual software release and platform are completely abstracted from your backend. This is very, very useful when you have multiple teams working on this stuff. You have like one team, you define what is your message contract, and then you're basically free to go. And you also have powerful personalization with no added backend complexity. You do not have to generate multiple messages on your backend. We do have a scale-out infrastructure that handles millions of this personalization in parallel for you. You do not have to do it by hand. So there is also a lot of other information. It was very much functionality. Now let's talk about other things. Delivery guarantees, telemetry and monitoring, and all these other things that are important. So we do not provide the delivery guarantee. This is because platform notification services do not provide the delivery guarantee. So they tell us that the message is received, and we basically tell you that that was a successful notification. So basically, we are best effort too. The only way that you can really provide delivery guarantee is by coding something inside your app. Some platforms allow you to code something to code like some handler that when the notification arrives, you can basically contact your backend and say this notification really arrived. However, the guideline is not to use that. And basically not to use push notifications for things that are important information. The notification is just a reminder to open the app. So all the important communication have to be delivered in-app. So what happens is that if somebody misses a notification, the next time that he opens the app, it's going to tell him that that something happened. And if he did not open the app and it's still important, you just send another notification. Notification Hubs does provide very, very deep telemetry, powerful telemetry. What you can do, you can track each and every outcome of the notifications. If they've been successful, they haven't been throttled, if the channels were expired, all these things are available to you in the portal, and we're actually expanding those with another full tab full of all the metrics that you could ever want. Right now, there are 12 metrics available for you. Some are platform specific, some are aggregates. And they are not only accessible via the portal, but are also accessible programmatically if you want to react to those. So you might have some specific throttling information. We do tell you if you start receiving some channel throttled errors, so you can react and change how you're sending notifications. What that means is that a certain device has received too many notifications. That is usually a sign that you're probably sending too many notifications to that specific person. Scale. The Notification Hub's infrastructure is fully parallelized. All our VMs are basically available for you to broadcast. So that basically means that you do not have to create multiple notification hubs to increase throughput or do any sort of fancy sharding architecture. We are already parallelized, and that also means that we're always ready for your broadcast. If you have 1 million devices, we're always ready to broadcast to all those people in a very, very short time. What is that time? During preview, the notification hubs are limited to 10,000 active devices. Now, if you need more than that, please contact us. But basically what we're doing is that we're going to go GA very, very soon. And when that happens, you will support millions of devices out of the box. You will not have to do anything for it. The expected latency of broadcast to your full audience, so if you have 1 million devices, it's a couple of minutes. So you do not, and that is the worst case, meaning that the last person that will receive the notification will receive the notifications after 2 minutes. This is, of course, we cannot really guarantee this because the platform notification service are the ones that are delivering the notification. If they're late, we cannot really provide a hard guarantee on that. But basically, what we will do is that we will deliver it to them at that speed. Okay, so platform support. At launch, we will support push notifications through all the platforms, WNS, APNS, GCM, and MPNS. We will have device SDKs for Windows Store apps, Windows Phone 8, iOS in Objective-C, and Android. At this time in preview, we do not publicly support Windows Phone yet, but that is coming really, really soon. And for server SDKs, you can use us from mobile services, from Node, from .NET, and we're working to have all the other backend platforms. But anyway, our service, all our functions are exposed via REST interface. The REST interface is public on MSDN right now, and all the things that you saw can be accessed through that REST interface. So the launch date is this summer, very, very soon. We will be in all Azure data centers, and that is really, really very soon. Okay, here are some resources. There's MSDN documentations and all the SDKs. And I'm pleased if you guys have questions, we can take a couple of questions. We have like a couple of minutes. And you can definitely talk to me after the presentation.
Can you go over pricing?
Unfortunately, I cannot go over pricing right now. But when we go GA, we're going to have a full announcement. No, we cannot push to Kindle. Let's talk about that. The question is, how do we avoid to have a specific user to receive too many notifications? We do not have a specific feature for that protects you from that. So basically what happens is that you basically have to code that on your own, which I understand that it might be complicated because you basically now have to understand how many people have received a certain notification. Usually, if you do have users and these sort of things, you will have to replicate some of the things that we have. This is actually how many other people are interested in this sort of per user throttling or per user protection mechanism. Okay. But we're looking into that. I understand. There are definitely some scenarios for that. Any other question?
So you mentioned using your typical localization.
Yes.
Does it do any automatic number dates for security?
No, we do not have any automatic of dates and number conversions. How I would do that is that I would use templates, and basically what you do is that you put into your input message all the different date formats. So you will basically have to, when you send a notification, you do all the formatting for all the different versions, and you always send them. And then basically we make sure that people receive the correct format. But we do not have anything more than basically string concatenation and basically, it's basically like a string concatenation engine.
If a user disconnects and come back in about like half an hour, what happens to the message during this time?
Well, the question was, what happens if a user disconnects for half an hour, and what happens to the notification? For those things, what we do is that we completely rely on the platform notification service. So every platform reacts in a different way for those scenarios. So GCM has a five message queue. APNS has a one message queue. Windows Store and MPNS do send the notification if the device stays in the temporary disconnected state. When it reconnects, they will receive the notification. I do not remember for how long they keep it, but that is basically what they do. There is one case that usually trips people up, and it's the toast notifications for Windows Store. Those ones are not delivered if the device is not connected. So that is, we talked to the WNS team, that is a conscious decision. They do not want to have toast really has to be real time. If you want to put something that appears if I'm not connected, when I reconnect, you should use the tile. That really depends on the platform. Yes?
Do you have any plans to support more sophisticated segmentation of devices by, like, say, location, being able to select not just tags, but devices that are near this geo point or within the radius of the location?
We are definitely thinking into those things. Sorry, the question was for the recording. The question was if we will support in the future some sort of segmentation that will take into account not only tags but also location and other things. Yes, we will. Yes. Oh, for a message. The limitation for a message depends on the platform. The incoming message can be very big, up to 64K. The outgoing message depends on the platform notification service. APNS is very strict. They actually have 256 bytes, so your payload has to be very small. Windows Store and Windows Phone support up to 4 kilobytes of data flowing through their system. GCM supports 1 kilobyte of data. So the incoming message can be very large. That is because you're using templates. You might have many, many properties. Maybe you're storing, 10 different languages. So it can be up to 64K. But outgoing, we give you the maximum amount from that the platform allows. Okay, I think we can wrap it up. Thank you very much. Thank you for staying 5 minutes longer away from your lunch.